So this is going to be a video just quickly on about stationary waves, because it's a term I've mentioned a few times before, but never formally defined. So a stationary wave is a wave which is forms between two fixed points, such as a guitar string. So there's two fixed points. If you pluck a guitar string, it will start vibrating up and down. Now, stationary waves have to vibrate at a certain frequency. It can't actually vibrate lower than a specific frequency, which is known as fundamental frequency. And when that occurs, one crest and one trough is formed. And the crest is known as an antennode, and sort of the troughs, or the points of equilibrium for fundamental frequency, they're not really given. They're called nodes. They're not given anything else called that. So you have nodes and antinodes. So antinodes are the crests, and nodes are the equilibrium point. And in fact, the fundamental frequency can actually be defined or derived as F is, so the fundamental frequency is 1 divided by 2 lots of the length times the square root of tension over linear density. Linear density is just mass over length, which can also be called mass per unit length. And actually, we'll jump straight into an example of using this, because I think this video is a bit too short. So here's our example. A guitar string of length 112 centimeters is plucked at the fundamental frequency of 88 Hz. The string has a mass of 7 grams. Find the tension in the string when it is plucked at the fundamental frequency. So go ahead and try this problem, and then when you're ready, come back for the solution. So I'm going to do it over here this time. So guitar string of length 112 centimeters, so I'll convert that into meters, so 1.12 meters. Vibrates the fundamental frequency of 88 Hz, so F is 88 Hz. And the mass of 7 grams, so the mass is 0.007 kg. So the first thing we have to find is the mass per unit length, or linear density. So mu is 0.007 kilograms over the length 1.12. We find as 1 over 160, which is also 6.25 times 10 to the 3, and then units are kilograms per meter. So now we need to find the tension. So F is 1 over 2L root T over mu. And what I'm actually going to do first is just rearrange to get to get T first. Just because this seems to be a formula a lot of people have actually messed up manipulating before. So 2L goes to the other side, then we square it, then times by mu. So you should get that T is 4L squared F squared mu. So T is going to be 1.12 squared, 88 squared times 6.25 times 10 to the minus 3. So 4 times 1.12 squared times 88 squared times 6.25, 10 minus 3. And that gets us 243 newtons. And that is the tension in the string when it is vibrating at its fundamental frequency.